Alright, so we're going to have a look at another question from the advanced mechanics topic. So this question says, an orbiting object has a mass of 5 kilograms and sits in a geostationary orbit. So this is an important detail in this question. We're asked to find the following: the gravitational potential energy, the kinetic energy, and the total energy. The first note we're given is that the object orbits the Earth. Okay, so we need to identify some things before we can answer this question. The first thing that we need to identify is that a geostationary satellite has a radius of orbit of roughly 36,000 kilometers. So this is a piece of information you need before you can answer the question. We also know that G, the gravitational constant here, is going to be 6.67 times 10 to the minus 11. So now let's try and calculate some of these. For part A, the gravitational potential energy, our formula for gravitational potential energy is U is equal to minus G, mass of the larger object times mass of the smaller object over the distance. So R in this case is the radius of orbit. So if we plug everything in, we get minus 6.67 times 10 to the minus 11 times the mass of the Earth. Now the mass of the Earth is a number that you'll see fairly regularly. It has a few different approximations. We're going to say the mass of the Earth is 6 times 10 to the 24 kilograms. This is just an approximation, but this is the one we're going to use. 6 times 10 to the 24 multiplied by the mass of the orbiting satellite. Well, that's 5 kilograms. This is divided by the radius of orbit, which is 36,000 kilometers. So that's 3.6 times 10 to the 4 kilometers. That's 3.6 times 10 to the 7 meters. So this has to be in meters in this case. So now we are going to plug all of this into our calculator. Minus 6.67 times 10 to the minus 11 times 6 times 10 to the power of 24 times 5. This is all divided by 3.6 times 10 to the power of 7. So this gives us minus 5.5583 ... times 10 to the 7. So I'm going to write this answer as minus 5.56 times 10 to the 7 to 3 significant figures. If you are told to round a different way, then round in the way that you're told, otherwise you will lose marks. In this case, either of these would be correct. I've chosen 3 significant figures. That's fine in this case. So this is our gravitational potential. So we've done this part. Now we need to find the kinetic. We could find the velocity, and then we could multiply 1/2 times the mass times the velocity squared. But we have another convenient relationship here when we're dealing with orbitals. The energy total is equal to the potential divided by 2, which is equal to negative of the kinetic. And what this means is the kinetic is equal to the negative of the potential, gravitational potential divided by 2. So we've just found the gravitational potential. That means we can find the kinetic by dividing it by minus 2. So we get minus 5.56 times 10 to the 7 divided by minus 2. This is minus 5.56 times 10 to the power of 7 divided by minus 2. This gives me 2.78 times 10 to the 7, and this is 3 sig figs, and this is going to be the kinetic energy in this case. So we've found the gravitational potential. We then used a shorthand formula for orbitals in order to find the kinetic. So we've now done part B. Now part C, we're asked for the total energy. Well, we have a formula for total energy. Energy total is potential divided by 2, which is minus kinetic. We've just found the kinetic, so this means the energy total is going to be negative of the kinetic, which is minus 2.78 times 10 to the 7, and this is also a 3 sig fig answer. And so this is our answer to this particular question. By knowing how to use these shorthand methods, we were able to find these much faster. You can do them using longer methods. They'll be perfectly acceptable. But if you can do them quickly, if you're in exams or tests, often the teachers, if they set up questions like this, will expect that you'll do them the fast way, because it will leave you more time for longer questions that can't be done a fast way. So we've got gravitational potential, kinetic, and total. And this is the answer to this question. Keep in mind, these are just approximations. Whenever you're doing anything in introductory physics, you're always just finding approximations, right? We've rounded a lot of values in order to get these. They're pretty good approximations, but they are only approximations.